Good afternoon, pilot teachers, and good afternoon, students. Thank you. Sit down. Okay, we're still looking at information of plate movements, and today we are going to look at plate tectonics and plate boundaries, mainly in Papua New Guinea. So much about looking at plate boundaries around the world. We need to also know our geology in the country so that we can be able to explain to people if they talk about volcanoes and if they talk about earthquakes and features that are created as a result of plate movements, and we can owe those explanation to plate boundaries or different tectonic plates within the country itself. So far, we have looked at movements of plates. We have looked at when plates converge, and we've looked at when continental plates meet up with another continental plate, what happens. Usually, fold mountains are created. When an oceanic plate meets up with a continental plate, we have subduction of the oceanic plate, and on the continental plate, we have fold mountains being created or formed. Other features that are formed also as a result of that would be volcanoes and fissures. And we also looked at when an oceanic plate meets up with another oceanic plate, formation of volcanic arcs, trenches. And today we are going to look at information on plate boundaries in Papua New Guinea. You should have a worksheet or a handout which will contain some of the background readings for us to be able to understand some of the plate boundaries within Papua New Guinea. You have a map there in front or on the monitor. And if you look at this particular map of Papua New Guinea, this particular map here represents some of the major fault lines that we have in the country. We talk about plate boundaries, and we've looked at major plate boundaries like the Pacific plate meeting up with the Indo-Australian plate. Where they meet, that is where the country, Papua New Guinea, also sits, along that boundary. But that is only one boundary or a major boundary when we're looking at the Pacific plate meeting the Indo-Australian plate. Within Papua New Guinea itself, there are also minor plate boundaries or fault lines that are found within our country. So if we look at this particular map here, this map here represents some of those active and inactive plates that are found in our country, Papua New Guinea. The key here representing the lines, the black lines that have the triangles on them, represents collision of plates, and the triangles represent the teeth on the top plate. In other words, if plates are colliding, the one that is subducting will have to be the bottom plate, and the one which is not subducting becomes the top plate. So the teeth then would represent, that is, the triangles shaded in black would represent that. Okay, the red lines on our map here, especially where Milne Bay waters are, that's the Woodlak Basin. And this is where we have spreading ridge occurring. And this is also an active seafloor in the country. The blue lines, they're supposed to actually show the spreading or the movement of a plate here, especially in the Bismarck Sea area. And the blue lines with the arrows representing the direction in which the movements are taking place. So we can see the movement towards the east here, and there's a movement also towards the west. And we can see ridges being actually formed around here because of that movement, and also rift being created as a result of that movement. Another important plate boundary is the one extending from the Woodlak area on the Solomon Sea, that is, all the way up towards Morobe province and up to Medang. We also have in the West Sepik and the Sepik area, that is, there is also a plate boundary which is actually marked and shown out there. And in the Pacific Ocean, that is, where we are to the west of, not to the west, but to the east of Bougainville, you also have a plate boundary which is actually drawn, and that continues on all the way to the top until it meets up with this particular boundary here, and that marks the North Bismarck plate. Okay, some of the minor plates within Papua New Guinea itself, we have the North Bismarck plate, this section here, the South Bismarck plate, this section here, of which New Britain sits, and also the islands which are volcanic islands to the coast of New Guinea, Long Island, Manam, Bam Island, Karkar Island, and etc., of which those islands are popular islands because they are also they contain some of the most active volcanoes that we have in the country today. Then you have the Solomon plate in Papua New Guinea, and that sits where the Solomon Sea is. And there is also the Woodlak plate in the Milne Bay province or the Milne Bay waters. Okay, our task today is going to be looking at describing some of the activities that are actually taking place where the boundaries of those different plates are in Papua New Guinea. But before we go on to looking at some of the features that are created as a result of those different plates that we have, or those different boundaries that we have in the country, we're going to look at some background information, and that background information is on the worksheet that you should have a copy of. So let's look at the background readings, and then we'll move on to our activities for today. Under the heading on earthquakes and volcanoes. Earthquakes and volcanoes, that's where I will start with the readings for our work on plate boundaries and tectonic plates in Papua New Guinea. It tells us there that earthquakes are direct manifestations of the geodynamic activity currently taking place near the surface of the earth. In other words, if we feel earthquakes, if there are volcanoes, obviously we know that there has to be something to do with tectonic plate movements. So they are a direct manifestation, manifestations of the geodynamic activity currently taking place near the surface of the earth. Their spatial distribution enables delineation of boundaries along which crustal movement is taking place. Studies of the elastic radiation they produce provide clues pertinent to the source mechanism. And apart from these tectonic aspects, earthquakes also pose a hazard to lives and property and can influence the development of any region where they occur frequently. All these aspects of earthquake are important in Papua New Guinea because it is one of the world's most seismically active regions. Between 5 and 10% of all earthquakes throughout the world occur here. Okay, let's look at distribution of the earthquakes and how they can also help us with identifying the major or those minor plate boundaries we have in the country. In terms of the recent theory of plate tectonics, which divides the world into several large, comparatively rigid plates, the situation in Papua New Guinea arises from the interaction between the northward moving India-Australian plate and the westward moving Pacific plate. These two large plates do not meet along a single boundary in Papua New Guinea. Instead, there are several small rigid plates all moving in relation to each other. Most of the earthquakes take place along the plate boundaries. Hence, the zones of earthquake or earthquakes defines the margin of those particular plates. You can make reference to the diagram on the board there, the map of Papua New Guinea, showing those plate margins or plate boundaries within the country. The earthquakes and volcanic maps, they show an accurate plotting of earthquake epicenters and depths. The epicenters plotted have been located by using recordings from at least 15 different instruments or seismographic stations in the periods between 1958 and 1970, apart from the two large Solomon Sea earthquakes of July 1971, are considered to be accurate to within 0.1 degree. At least 6 seismic zones can be recognized, and this involved the interaction of 5 or possibly 6 rigid plates in Papua New Guinea. Let's look at each one of those. The most active plate boundary or the most active boundary is that associated with the northern margin of the Solomon Sea and is manifested by the New Britain and Solomon Island arc. The New Britain arc, it contains a typical Benioff zone of earthquake or earthquakes that dip to the north beneath New Britain. So it's this area here that we are looking at as to be considered the most active boundary that is found within Papua New Guinea. The northern part of the Solomon Sea, this area here. At the western end of the arc, which is near 146 degrees east, that particular zone dips almost vertically, and that contains the Long Island nest, which is a small volume of intense earthquake activity situated at a depth of about 200 kilometers just south of Long Island. So to the west of the island arc, so we are now saying that this is the island arc. To the north of this particular plate we have just mentioned sits the Long Island, and to the south of it is what we are talking about in terms of a small volume of intense earthquake activity, which is situated at a depth of about 200 kilometers. So to the south of the Long Island. So here we are looking at, that's where the boundary is also found. Beneath New Britain, the dip of the seismic zone decreases from west to east along the arc, and under East New Britain, it dips only about 50 kilometers. Several deep earthquakes from the arc at the depths greater than 300 kilometers have been observed under the Bismarck Sea. So now we are coming to this area here. That's where the Bismarck Sea is. And they represent the underthrusting of the Solomon Sea Plate beneath the Bismarck Sea at a rate of about 9 centimeters per year. So underthrusting, that means that this particular plate is actually moving this way, this plate here is moving up that way. Where they meet, it is this boundary here that is actually formed. So what do you think would be a feature that is found along this particular area? A trench, yes, obviously. And this plate here is moving and then subducting under this particular plate here, because this is the top plate. Okay, so a trench then is formed along this area here. Okay, we move on. It tells us that the New Britain arc ends abruptly at the southern tip of New Island, where the strike of the seismic zone swings through 90 degrees, and a new zone that is striking parallel to the Solomon Sea chain, or the island chains, represent the boundary of the Solomon Sea Plate with the main Pacific Plate. So we come to the end of that arc we're looking at here, and then you have a 90-degree turn to where the boundary of the Pacific Plate is. Between New Island and Bougainville Island, the seismic zone dips to the east and contains most of the very deep earthquakes with a depth greater than 500 kilometers below, reported from Papua New Guinea. So some of the most deepest earthquakes or earthquake recording is actually recorded along or around this area here. It also tells us that near the northwest of Bougainville Island, we're looking at the northwest, so here along this side to the northwest of Bougainville Island, this section here. The dip of zone changes abruptly and becomes vertical, and few earthquakes are reported from Bougainville Island. The rate of underthrusting of the Solomon Sea Plate at this boundary is about 10 centimeters per year. The southern boundary now of the plate is marked by a shallow zone of minor seismicity, which extends from eastern Papua to New Georgia. So here, eastern Papua towards this section here of where Solomon Islands is. It also tells us that this zone bifurcates east of Woodlak Island to contain what we call the Woodlak Basin. So it's this area here. The basin may be a spreading center, but the level of seismicity is too low to reveal its tectonic significance. So the level of seismic activity along this area is a bit too low to identify really what is actually not to identify really what is happening out there, but the seismicity or level of seismicity is too low to reveal its tectonic significance. Along the north coast of the main island of New Guinea, so we are looking at the north coast now of the main island of New Guinea, so this area here. The earthquakes represent a separate zone of thrusting. Instead of a well-defined Benioff zone, there is a large shallow slab or wedge seismically active dipping to the south. The earthquakes which are observed here occur at depths of less than 200 kilometers and represent interaction between the Indo-Australian plate and the Pacific plate, west of 142 degrees east, and the South Bismarck plate east of 144 degrees east. In this particular region, crustal compression is actively taking place at velocities between 3 and 10 centimeters per year. But mountain building, rather than underthrusting, is the final result of the interaction. So this is the one we're referring to along this region here. One of the most remarkable seismic features in Papua New Guinea is the zone of shallow earthquakes that extend east-west across the Bismarck Sea at about latitude 3 degrees south. So we're looking at from east to west along the Bismarck Sea, that is, and that's the area we're referring to now, this section here. The maximum width of this particular zone is only about 40 kilometers, and it extends from the southern width of this zone. Sorry, I'll repeat that. The maximum width of this zone is only about 40 kilometers, and it extends from the southern end of New Ireland to the New Guinea mainland, except for what appear to be two seismically inactive regions near the eastern end of that particular feature. Studies of the focal mechanisms of earthquakes suggest that it is a large left lateral strike-slip fault with a rate or with a slip rate of about 8 centimeters per year. And this large fault marks the northern boundary of the southern Bismarck or the South Bismarck Sea Plate. North of the fault zone is the North Bismarck Sea Plate, and its northern boundary is the West Melanesian Arc. The level of earthquake activity associated with this arc is actually very low, which suggests that the relative velocity between this plate and the main Pacific plate is small, less than about 2 centimeters per year. Only about 9 earthquakes from this arc are plotted on the map of Papua New Guinea, which we will look at later on. Okay, so with that information, it basically perhaps gives us an idea of the minor plate boundaries that we have in Papua New Guinea and some of the features that those boundaries are actually associated with. Anyone with any queries or questions now with regards to that information on plate boundaries in Papua New Guinea? Maybe it will take us some time before we can digest this information and really get to know a little bit more about those different boundaries we have in the country. Let's do some activities, and maybe for those activities you can work in pairs, discuss your answers, and then come up with your answers. The activities are looking at what we have read already, and maybe making reference to that map showing us the plate boundaries and the major fault areas in Papua New Guinea. Explain how the New Britain Trench was formed. So you'll have to locate, first of all, the New Britain Trench, and then you explain how it was formed. Number 2, describe the plate movement in the Bismarck Sea. So you'll have to make reference to the information we've looked at, and you make reference also to the notes, and you explain the plate movement occurring in the Bismarck Sea. And number 3, you'll be also required to describe the activities taking place in the Woodlak or along the Woodlak Plain. Sorry, not Woodlak Plain, Woodlak Plate. Okay, we look at those three activities again. Number one, you explain how the New Britain Trench was formed. Number two, describe the plate movement in the Bismarck Sea, or describe plate movement in the Bismarck Sea. And number three, describe activities in the Woodlak Plate. You'll have to make reference to the readings that we have done, and you can also make reference to the map of Papua New Guinea showing us the plate boundaries in the country. Do those activities in pairs so that you can come up with your answers quickly, and we'll double check on those answers. The first one should be easy for you to work on. Explain how the New Britain Trench was formed. Yes? You want the questions again? Okay, we'll check the questions again and make note of the questions quickly. First one, to explain how the New Britain Trench was formed. Number two, describe the plate movement in the Bismarck Sea. And number three, describe activities in the Woodlak Plate. You got those three questions? Everybody? Okay, now we'll go back to the map so that you can use the map to help you with the completion of those three exercises. Make reference to your readings, or the readings that we went or looked at a while ago, we went through together, because those readings will contain answers also to those three questions. Yes. The second question is the plate movement in the Bismarck. Describe the plate movement in the Bismarck Sea. Just look at the map and maybe look at your readings and explain what you think, what type of movement is taking place there, and the features that could be created. And the third one is describe activities in the Woodlak Plate. Yes. 10 minutes. Okay, I'll give them 5 minutes and I'll do the correction again. You have a question? Anyone need any help with those questions?
About describe activities, like how to describe such activities like volcanoes or
Those are features that are there. Obviously, yes, you can say talk about volcanoes, but what can yes, exactly. What can you see from that particular map? What is it showing? It's a basin. So with the Woodlak Basin, what is actually really happening to that basin? So find out that where that happens, there is a large lateral strike slip fault, which is also occurring there around those regions. Second last paragraph. Of zone. It's a zone of earthquake. You were not here. I put up the definition on the board. Since you asked, I'll tell you. Is this your rough workbook? Yeah. Okay, I'll use a pencil. You have plate movements. What will happen is the lighter plate subducts, right? Okay, upon subduction, you start having those zones where there is a focus or center, the beginning of where earthquakes occur, because of the fact that you're moving down to another particular layer and you're meeting up with the other rocks and there is contact. Earthquake move. That this particular zone, as we're moving further and further down, is referred to the Benioff zone. Yes. I gave the definition to the students on the chart. So you double check to see that you have that definition. So a lot of it appears from the work, so you need to know what it is. Okay, we'll have to check on those activities now. We'll make corrections to those activities. We'll check the first one. The first one, I think the first one is straightforward. And that is to explain how you think the New Britain Trench was actually formed. How was the New Britain Trench formed? According to what you have studied and according to what you've seen from plate boundaries in Papua New Guinea. Anyone would like to tell us what you've got for your first answer? How about Gao? What do you have? Explain how you think the New Britain Trench was formed. It's this particular trench here we're looking at, this area here. This is the New Britain Trench. And if you hear and maybe note the keyword which is given, a trench, you should all know how a trench is formed. So therefore, even without looking at the information, you can still be able to work out how this particular feature was formed. We're looking at the New Britain Trench. This feature here in Papua New Guinea. How was it formed? Frank? Kiran, okay. Kiran will explain to the class.
It was formed when the South Bismarck plate collided with the Solomon plate, which the Solomon plate subducted, forming the trench.
Okay, let's check. He said the Solomon plate colliding with the Bismarck plate, resulting then in the subduction of the Solomon plate, forming the New Britain Trench. Check. The triangles are supposed to show the colliding plate, of which shows us the teeth on top plate. So if it is on the top plate, that means the Bismarck plate would have to be the one that subducted, and the Solomon plate was the one that's on top, resulting in the formation of the trench. Okay, so his explanation is correct. Definitely Bismarck Plate, Solomon Plate colliding to form this feature here called the New Britain Trench. Solomon Plate subducted to form the New Britain Trench. We've noted the process in the formation of this feature is simply the collision of the Bismarck Plate with the Solomon Plate. And where they collided, subduction occurred, and the subduction occurring to actually form the New Britain Trench. Okay. We check our key on the map. Okay, we're looking at maybe the explanation to the teeth here to show the top plate, and according to Gideon's explanation, he says that the Solomon Plate subducted beneath the Bismarck Plate, and the reason being that if it was the Solomon Plate that that is on top and not subducted, then the teeth should be on this side, and he is definitely correct in saying that. So we will go with what Kieran has given earlier on. Solomon Plate colliding with the Bismarck Plate, resulting in the subduction of the Solomon Plate, forming the New Britain Trench. We all happy with that? Okay, good. Let's move on to the second question. The plate movements in the Bismarck Sea. It's this area here now that we're looking at. Can someone explain the plate movement in the Bismarck Sea? Ovio. Ovio is going to explain.
The North Bismarck Plate slides past the South Bismarck Plate.
Okay. Passing like, you know, to the north, south, east, or west. Give us the direction according to the information.
North Bismarck Plate travels eastward, west, and the South Bismarck Plate moves eastward.
Okay, good. So we are looking at the North Bismarck Plate here to the west, South Bismarck Plate to the east, and what is then formed in between there becomes a strike-slip, or you have a strike-slip fault, which is actually created as a result of the movement. Remember the St. Andreas fault? One plate moving past the other plate, resulting in the formation of the fault, the St. Andreas fault. Similarly, in this region, this is what is happening to have formed the strike-slip fault in this particular region. Okay, good. The movement is the North Bismarck Plate moving to the west, the South Bismarck Plate moving to the east. The second last paragraph from your reading will also give you the feature that is created as a result of this movement. Okay, we move on. Finally, the last question. What type of activity is actually occurring within the Woodlak Plate? So it's this particular area here we are referring to. The Woodlak Plate, what type of activity is happening there? Doreen. Doreen? In other words, just give us some of the features you can see that is actually occurring within this particular area. Quickly, Doreen. Anita, going to help Doreen? Or Doreen, you have an answer? Okay, let's go, Doreen, quickly.
A transformed fault.
Okay, you have a transform fault, which is actually occurring where? Where the Woodlak Basin is. Okay, that's one of the features which is actually formed occurring within this region. And she's definitely correct. If you look at this particular diagram carefully, you have two things. You have a spreading ridge occurring, represented with a red line, and the blue line representing a transform fault, and that is a step between two different plates within that particular region. So two lots of activities, a spreading ridge in the Woodlak Basin, and at the same time you also have transform fault also been found within this area. So this whole area here, we are looking at what we call, on the Woodlak plate, we have the Woodlak Basin. There is also another important point we need to include for that particular plate, the Woodlak plate that is, and if you look at the last, see the last paragraph, it is the last paragraph of the third lot of readings we've looked at. It tells us about the southern boundary of the plate, which is marked by a shallow zone of minor seismicity, which extends from the eastern part of Papua New Guinea to New Georgia. And it tells us that this particular zone bifurcates east of Woodlak Island to contain the Woodlak Basin. That's this section here. This basin may be a spreading center, but the level of seismicity is too low to reveal its tectonic significance. And that's another point that you need to be made aware of when we're looking at those features in this region. Okay, that will also bring us to the end of our lesson. Your homework. Your homework is to ensure that you understand what information we have already looked at and gone through in our reading for plate boundaries in Papua New Guinea. So I'd like you to go over the information again. I'd like you to read through that information for your homework. Okay, class, if you can now stand up. To the pilot teachers, our keyword for today, that is lesson 29, is Stanley Mountains. Good afternoon and thank you, students.